Okay, we're just waiting for everyone to sort of sit down. Yeah. Sorry, Alex, give me a sec. Cool, okay, looks like we're getting there. Sorry, I know you're blind in this. Cool, looks good. Let's go. Okay, great. So thanks everyone for coming out. It's amazing to see so many people here. You know, React Native London has been remote for a very long time. I think this is really like a big milestone for us to get everything back in person. And I'm really blown away to see so many people in the audience, you know, and I'm sure loads of people online as well. Yeah, you know, it's really great to see everyone. And I want to give a big, massive shout out to Immediate Media for hosting and all the React Native team, you know, for putting this together. So a round of applause if you guys would. Great. So a little bit about, you know, Theodo, which is the company that puts this together. You know, we're a lean product engineering company. You know, we use React Native, obviously, and loads of other tech that you can see on the board. And of course, more importantly, Immediate Media, who's the host today, is also hiring React Native developers. So I'm sure a lot of you in the audience are going to be React Native devs. So definitely chat to Ash or send your CV to this email or come to chat to me afterwards. I'll put you in touch. Great, cool. So our first talk is Alex Moureaux, and he's going to be talking about profiling your React Native apps in production. So yeah, hand over now.
I need to get rid of those. And up. Oof, clear this. Go here. Okay, I'm ready now. All right, can I just start by thanking, well, React Native Europe, React Native London, sorry, for organizing this, because I saw them, doing all the tricky setup and everything to have this both in person and via Zoom. And wow, that's pretty amazing. So thank you so much, and thanks so much, Immediate Media, for also hosting the event, because I asked for a smaller lectern and they provided, because this was definitely like, no. I was not as tall as their expectations, I guess. But yeah, bit of introductions. I'm Alex. Hi, I'm a tech lead at BAM. We're based in Paris and we develop mobile apps, mostly in React Native. And we're part of the Theodo group. So we work with Theodo in London as well on React Native stuff. You can follow me on Twitter if you want to hear about performance, because this is basically what I talk about these days. And actually, why do I care about this? Well, many reasons, but I like this one. Let me tell you a short story. So at some point we had this client and they wanted us to develop both web app and mobile apps. So we're like, cool, React developers, we're going to do it in React Native plus React Web. Cool, that's going to be awesome. And they had actually an amazing set of technical standards for the project. So on the web app, they required us to have a Lighthouse score above 90, initial time to render under like a few hundred milliseconds, and some other metrics. Like, that was really nice. On the mobile apps, they told us their requirement was it should not lag. That's it. And wow, that's a bit frustrating. Like, it feels like measuring performance for mobile apps is not as mainstream as for the web, and it's kind of annoying. And when you Google that, okay, what makes an app performant? What can you do to make your app performant? Usually you can see this video. So the video, I'm not going to show it, but it's in the slides. They explain why the holy grail of performance should be that your app should run at 60 frames per second. So for example, if you scroll your device, your app is responsible for being able to show 60 images of your app per second, so that it feels smooth. So why 60? Well, it's fast enough for the human eye, usually. There's less perceived benefits in higher numbers, although that could be arguable. And one important thing is that the frame rate should be constant. So if your app is like displaying 60 frames per second, but suddenly it shows like only 50, you could be like, 50 is close to 60. But actually, usually the human eye is very nice at spotting issues like that. The question we could ask ourselves, because this is React Native London, is this true for React Native apps? Well, yes, this is true, because React Native is essentially native. You have JS driving native components. So we also need to aim for 60 frames per second. But another question is this enough? Well, no, because we also have the JS thread. So spoiler alert, this is not entirely true. with the new re-architecture, so spoiler on the next talk. But essentially, what happens if you, for example, you use your app, I'm clicking a button on my app, the native component is gonna, detect that click, and it's gonna need to send it to the JS side, right? And then the JS side, if you have, for example, a touchable opacity, wrapping this native component and driving this native component, you're going to have an on-press. And so on the JS side, well, you're supposed to process the click event from the native side and execute what you put in the on-press. The issue there is that if the JS thread is too busy, well, you have only one. So if it's too busy, it's not going to be able to do anything. So it's not going to be able to respond to the click. So actually, let's show this just now. Oop, disappeared again. Sorry. Up. Let me hide it again. So if I share the screen of my phone with neat little tool by Genymotion. There you go. Up, there's my phone. So I implemented a very, very fancy app. Yeah, it's beautiful. Design made by me. I'm not only a developer. No, I'm kidding. It's yeah. Well, and yeah, it's well. Let me quit it actually to just restart it. But as you might have guessed already by seeing the text, wait, where was it? Oh yeah, example. Apparently my alphabetical order is messing. I'm not so good with the alphabet, but yeah, example is here. And yeah, just the standard React stuff, not so fancy actually. I click me, and you see I've been clicked 2 times, 3 times, 4 times, 5 times. Okay. So I have also a button there, kill.js, which begs to be clicked. What it does is it calculates. I mean, if you're curious, it calculates the Fibonacci suite recursively up until like 42. So it's yeah, that's why it kills the JS thread, because it's doing it on the JS thread. So let's see what happens if I click it and I try click me. Like you don't see it, but I'm clicking like crazy. I'm clicking click me. Nothing happens. And yeah, there you go. You can see I've been clicked 28 times. So just to show that, of course, this is the stuff we want to avoid, because your app could be running at 60 FPS, but if the JS thread is dead, your app is not going to be responsive, because a lot of stuff happen on the JS side. So one thing to know is that, well, you don't see it so well, but on the top right, you have the performance monitor, which is quite nice. You have UI FPS. I mean, it says 59.8 due to how it's implemented in React Native. Actually, it should be 60. And if I do kill.js, you'll notice that the JS goes to -2. Well, you don't notice it because you don't have like amazing super eyes and it's very small. But this is also why we have created this plugin. Wait, no, not this one, spoiler. Which actually does that for you over a period of time and draws a graph. So if I do kill.js, if I zoom out a little bit because this is big, yeah, you can see that the JS stayed dead for a while. And cool, as a bonus, where we were talking about Lighthouse score, it prints it out as well. So yeah, you can see that I clicked kill.js just when it goes down. You can see that the JS FPS is going to 0, and this is definitely what we want to avoid, as well as the UI FPS being at 60, to avoid the app being unresponsive and laggy. But this talk is not entirely about that. So so React Native Performance Monitor and the plugin that goes with it. I think it might not fit all use cases. So tonight I want to experiment a little bit with you guys. Because like, I don't know, well, first, I mean, your app might actually be running at 60 FPS, but be struggling to do so. Like if you're displaying your app at 60 FPS, but your phone is heating up, like I'm not going to call your app performant, because, well, it's going to use all the resources on the phone, so it's not so great. Also, a fun thing you might want to do, what if you want to compare your app's performance with your competitors? You probably don't have their code. So installing Flipper plugins, or even if it's not React Native, like how do you what do you do? And also, what if you want to ensure that you have no performance regression if you do a big architecture? So as I was saying, Fabric changes a lot of things. Actually, it's going to be lighter on the JS thread, but some other stuff might happen. So you might want to check, if you want to check before Fabric and with Fabric, like this method of testing might not be right, because maybe the JS thread is going to be better, but maybe some other stuff that don't appear in the measures before have become worse. So what I really like to do, very simply, is measuring CPU usage. Why? Because on Android, and I like to measure on Android because, let's face it, Android devices on average are slower than iOS devices, just because, well, most of them are cheap. And to make them cheap, of course, you don't have as good CPUs as iOS. And so, yeah, measuring CPU usage is easy on Android, as I will show. It's completely objective. It doesn't depend on technology. Like you could, compare React Native with non-React Native apps, or if you're doing a complete React architecture, you could compare Fabric versus non-Fabric. Well, what's the CPU usage? And also, well, in React Native, what's kind of nice is I was saying we should avoid 0.js FPS. Actually, it directly correlates to basically the JS thread is using 100% CPU usage. So it's using it for a while, and that's why it cannot respond to the events, because it's just killing one CPU. And since we have one thread, it can only use one CPU. So by one CPU, for example, this phone has 8 cores. So technically it can do 8 things in parallel, but the JS can only be one thing in parallel. So if it uses 1 core in total, then the app's not responsive. So this is what we want to avoid. And yeah, showtime. So I was saying that I wanted to show some stuff and experiment with you guys. Let me go back to this. And maybe I should zoom in a little bit for our friends on the Zoom. Yeah, that should be fine, I hope. And with Android, you get something called ADB. It's likely you've used it before. It's called the Android Debug Bridge. But basically, it's a set of commands that you can run on your phone, and you have a lot of stuff like this. Actually, if you run in a React Native app, React Native Run Android or Yarn Android, a lot of stuff are run for you with ADB. But for example, you have ADB install. You can, install an APK if you're too lazy to rebuild your app and you already have it built. But what's really interesting is, well, Android actually runs on Linux. So you have ADB shell, which opens a shell inside my phone here. And it's kind of cute. I can run comments like, I don't know, well, what's, I guess, the most famous comment everybody knows, I guess, echo. Hello, React Native London. And then, it just, basically, I'm in the shell of my device, and I'm actually echoing React Native London inside the device. Well, obviously the output is passed back to the computer. I can do all sorts of things like pwd. Well, I'm at the root, so yeah, ls to list off all of the folders. And also, as a convenience, I can do ADB shell ls, for example, to execute the comments. So, for example, I'm using ZSH, so it's kind of nice to have the history of comments. It's kind of cool. And yeah, you also have a lot of stuff actually available in ADB shell. You have some stuff that are very particular to the Android world. For example, if you want to see the Wi-Fi password and type it in your phone, you can just do this. Whoop, if I can get the phone back. Yep, there it is. Yeah, it's hard for me to not show just this one. Oop, hello. Yeah, okay, I'm here. So I don't know if I want to search things to do in London, because I'm in London for the weekend. it just types in. You saw that I didn't type in with my hands. Then I don't know, some fun stuff also if you want to. So ADB shell input, you can just type it in and it will show a lot of stuff that you can do with it, and you don't necessarily need to have an extensive end-to-end tool to do that stuff like Appium or Detox. Sometimes it can be easier. I like this one. Like you can actually scroll. I think it's fun. But okay, enough chit chat. What's really interesting here is that if it runs on Linux, so on Linux you have some comments related to performance, and this is what interests us tonight. Namely, you have PS and top. So let me keep my phone actually. Top is really neat. If I do ADB shell top to run top on my device, this is awful because this is too big. Whoop. Right, let me do it again. ADB shell top, still too big. Okay, this is not too bad. Whoa. Okay, needs to be a bit smaller, I guess. Sorry about that. Okay, third time's the charm. ADB shell top. Yeah, that's kind of nice. Okay, hopefully not too hard to see. I see people flinching their eyes in the first rank, so probably it's too small. But there's a lot of stuff happening on that screen. On the right side, you have the name of processes on your phone. And there are stuff that look like bundle IDs of apps. For example, I have com.twitter.android going over the top at some point. Apparently, basically, Twitter is doing some stuff in the background that I'm not aware of. And you have CPU usage here. And basically, whoa. Okay, so it's a bit weird when I'm zooming in. Huh. It's gonna keep doing that, isn't it? Basically, it ranks. This is horrible. It ranks. We're not gonna stay too long on the screen. I reassure you. Yeah, I will try again. It ranks processes by CPU usage, and this is basically what we want, right? Because it just outputs here the CPU every 3 seconds, CPU usage over the last 3 seconds of any app. If 3 seconds is too short, we can just do .d 0.5 and it's gonna input it every 500 milliseconds. So for example, if I take my, that's gonna be tricky. Okay, I'm gonna try smaller again. You're gonna have to trust me on what I say if you can't read. If I take my example app from previously, I do kill.js. You see com.example actually appearing at the top. And, whoa, Facebook is, we'll get to that later. What the? That's crazy. Yeah, if I do kill.js, it's using about 100% CPU. It's using more than that. You see that, I mean, you might not see, but the numbers go a bit higher than 100. It goes to like 120 or something. This is because top actually says that my phone has 8 cores, so it can go up to 800%. It's 100% per core. So when I do kill.js, I have the JS thread taking 100%, and there's still like 5 or 6% CPU percent being used by, well, usually the display, like the main thread to display those, because it's still displaying some stuff when I click kill.js. And yeah, this is pretty much what we want. With a comment, then you parse it and you have CPU usage on your phone, on your app. But we could go a bit further because it would be nicer to know if, so for example, if my app is taking 100% CPU, there is a big difference between my app taking 12.5 on 8 cores, because 12.5 times 8 equal 100. So it's taking like a little bit of the 8 cores. versus it's taking 100 on one core. Let me say that again. So it's better if I'm taking like only a little bit on each cores versus 100 on one core. Why? Because, for example, if it's taking 100 on one core, it means that it cannot do more. Like it means that this thread is using too much on a thread, just like the JS thread. It's using 100 and it cannot do anything more. So probably there's something going on in the app and it's blocked and there's something weird happening. So it'd be nice if we could see threads, and we can. So that's cool. With -h, like threads, I don't really know why -h, but there you go. It's even crazier than before. But on the right side, you see all the threads, but you see all of the threads of all of the apps of your phone. So that's kind of crazy. You can see actually top at the top, which is fun because this actually is, yeah, measuring performance can be performance heavy. That's kind of, yeah, weird thing. It's actually taking a lot. But if you just want to get the threads for your app, you can do .p and select the process ID. So each of the process have a process ID. And if you're like me and you don't know how to get the process ID of your app, like if you want to do anything with ADB, you just Google ADB do this on, and usually it works. Like you can do pretty much anything. So turns out that it's ADB shall PDOF your bundle ID. So my bundle ID is com.example. I do ADB shell PDOF com.example, and I get the process ID of my app. And then if I do -p of the process ID of my app, I should get only the threads for my app. If I do kill.js now, I have MQT.js at the top, which you might have guessed is the JS thread. If I do kill.js again, yeah, still at the top at 100. It's actually going at 102, so that's kind of weird. I don't really know what's up with that. But yeah, that's pretty much it. So essentially, you could just parse this output and you have a performance monitoring tool in production. Oh yeah, actually, I wanted to show something, like just to show that this is in production. So Facebook, because it was kind of acting up before. Facebook. So these are the threads for Facebook, and some crazy stuff is happening. But for example, if we go to the marketplace is React Native. Oh damn, it's, yeah, the marketplace is React Native, so you don't really see it. But if I scroll, the MQTGS should get a bit higher, because to be honest, I think they have really badly implemented their list. I think, you know, some memo in there probably is missing, because yeah, this is an S10, this is not a bad phone, but I'm just scrolling and yeah, it gets up to almost 100. Yeah, 100. There we go. Remember what I was talking about? Like, we don't want 0 JS FPS equal, you know, we don't want 100% JS CPU on the JS thread. Well, this is what's happening. And yeah, we don't want that. So essentially, you could just parse this output and you can measure performance in any production app. So I've done that and made it into a Flipper plugin so that you don't have to do it yourself. So I thought now we could have a little bit of fun with it. And I'm not exactly sure it's published yet, because I published it this morning and apparently it takes a while. But anyway, I'll give you the links at the end. If I click here, auto detect, for example, Facebook, I can just click start measuring, and it's going to do essentially the same as before. And oops, some actually test string here that I left. Ooh. Okay, this is the first time I'm speaking in public in like 3 years, and this happens. Damn. All right. And you can also see poof, the JS thread here going like super up. But if I do stop measuring, I can also see all of the threads here. And of course, like if I want to have some fun, I can just select, for example, I don't know, Facebook.katana render thread, and I can display all of the threads I want. And you can clearly see here on the graph that, I mean, it's going to 100 for the MQTGS, so it's really not good, and it's just doing that. And by the way, this is definitely a flat list because when I do this, you can see some white. Since all the virtualization happens on the JS side, the JS side is dead. It doesn't know what to display anymore, and the JS side is like the scrolling continues, but then the JS side cannot keep up to say, hey, you should display this. So I asked on Twitter what were some apps that we could check, and I've heard about Coinbase, so we could take a look at Coinbase. And yeah, no suspense. I don't have any money on Coinbase. Like I'm sure you're all expecting. Yeah, it's 0. Yeah. Auto detect. So up, start measuring. And there we go. So here, kind of hard to see, but I'm not doing anything on the app. It's running 89% total CPU usage. I don't really know what's up with that. If we do stop measuring, we can check below. Okay, definitely not the JS thread. So here, if React Native was detected, it's just yeah, it's going to display the JS thread automatically here. But here it's not very high. So we could check what's happening here and order by average CPU usage of all the threads. Well, without knowing the code of the app at this point, it's kind of hard to know what's happening. So Coinbase.Android, I have no idea why this happens, but basically, no, it's definitely not like ADB shell top prints out the same. So just a note, I'm not actually parsing top output. Top actually reads from /proc/something files on Android. If the code is open source, if you want to check it out, and I do the same basically. And in there you have the name, but I guess the name cannot be bigger than, I don't know, many characters. And so that's why sometimes, well, it's supposed to be Coinbase.Android, but sometimes, yeah, it's different. So usually the threads associated with your bundle ID is the main thread. It's the one responsible to display frames. So if this one is going at 100%, probably your app is not going to run at 60 FPS. But he also has a thread called the render thread, which is supposed to be dispatching dispatching comments to the GPU to make some heavy calculations, typically animations. So I'm not really sure what's going on. Oh, and the other one that's quite high is MQT native modules. This is by default, if you have a bridge, a native bridge, it's going to run in this thread. So it looks like on the JS side, nothing much is happening, but it seems like they have a bridge doing some stuff. Obviously, if we're not Coinbase, we can't really know. And it looks like they have something taking, like, I don't know, an animation, or maybe it could also be a web view. I had some bad experiences with web view taking a lot of stuff on the render thread. And I think if we do the same, just like Facebook, let's see, start measuring. Okay, let me reset, start measuring. And I started to go down. It's pretty smooth, but it's getting kind of, wait, let me just get the render thread all the time. Yeah, the render thread, which is one of the threads responsible for the 60 FPS, is starting to be really in trouble. And you have here like actually processes with high CPU usage detected, which you definitely don't want. Well, yeah, here the render thread is dead, and actually, well, it's probably looking laggy here, but it's also looking laggy here. So the app is actually not displaying at 60 FPS. My guess would be that those articles are maybe web views or something. I don't actually know. Any guess is as good as mine at this point. But yeah, I mean, something could be optimized here. Yeah, let me do quickly, maybe. Oh, I can do also Uber Eats, because someone talked about Uber Eats, but see, auto detect. Whoop, nope, Uber Eats, yeah. Start measuring. Oh, you can see my address, cool. Actually, there's no JS thread. So this is not React Native. I think Uber Eats mentioned at some point that they have a restaurant app in React Native, which I haven't tried, but this one is not React Native. And actually, I could try the same. It gets also quite slow at some point. So it doesn't, you know, be it React Native or native, you can have performance issues or even Flutter, actually. I think it's the French train company. They built their app in Flutter, and they actually have lag on iOS. Yeah, I mean, it's not necessarily a technology problem. And just to, someone on Twitter mentioned also, he was the first one to respond. And oh yeah, it's all about this one. I thought it would be a good competitor to Facebook, because it's a social network. I don't really know it, but there's a list, lots of media, so we could try it out to see if it's better than the Facebook list. So let's see the JS thread. So the JS thread goes up, so I think it's a flat list. Oop. Oh damn, that's, oh crap. I hope he's not watching. That's awkward. This did not happen during my test. Maybe it's something with ADB, etc. I don't know. Oop, wait. I think, yeah, I'm gonna reload. Electron app. Okay, let's go at it again. Start measuring. Okay, there you go. And yeah, I'm sorry. I prepared this and it was not doing that. Like, I wanted to say actually that the scrolling was kind of nice and the CPU was not going up so much. I don't know what happened. I was gonna say like they're a nice Facebook competitor. Maybe there's something to be done there. But yeah, basically, yeah, some stuff happened. I don't know. I'm gonna reset, clear it. Yeah, so I mean, I think, yeah, let's stop with the demo. And just getting back to the slide, this means pretty much we can do anything. I think we can objectively compare framework performance, and this is something that I want to do because I've been asked this question a lot of time, like, what is better, Flutter, native, React Native? So this is something we're going to do at BAM, the company where I work, to have a nice comparison. So CPU is one thing. There's also FPS, RAM usage, and other stuff that will come into play. You can have E2E performance testing. Like basically, so the thing that I've done on Flipper, it uses a another package that you could just use on a CLI tool, or you could just use, I don't know, if you run an Appium test or a detox test, you just pull the process, and then you could have something that just, you know, checks the average CPU usage over I don't know, something you do in the app. Be sure to always average it because performance measures are not deterministic, but you could basically compare and do stuff like this. Probably more on this also in the coming month. And to be honest, I feel like Lighthouse for mobile apps is getting closer, because if you can do this, then basically just put like Appium. So for those of you who don't know, I kind of like Appium. It's a end-to-end testing tool. What's nice about Appium is you can put any app in there. You don't need to install anything. It can test, click, and do stuff in any app. So could imagine something like you pass an APK to a tool. It's going to run some random Appium stuff, clicking, scrolling, etc., measuring CPU usage, and it could attribute a score. So that's my dream, but hopefully, you know, also more on that later. It's going to be a fun year, I think, for performance, at least for us at BAM, but I hope you'll also be part of this because I think performance is just, we don't measure performance enough. So if you want to hear more about that, you can follow me on Twitter. There is also the repository, but I will share better links on the event, and I guess there is an event page, right? Yeah, and on the Twitter. So yeah, that's it for me, but I think it's time for Q&A now.
Is there like a mainstream app that we would know about that does have performance?
Yeah, I'm gonna repeat the question for the Zoom people. The question was, you've shown us how many apps? 3 apps which had all performance issues. The question was, is there any app without performance issues? It's a good question. I thought the last one was quite nice, actually. So kind of sad that this didn't happen. But what I notice is at some point, if you don't measure performance at all in a project, you're always going to have performance issues. So actually, that's a good question. I haven't played enough with like apps to see really an app without any performance issues. But it happens a lot that I help on some clients project and I see that they've coded the app for like 3 years. And you go and you're like, you measure performance and you're like, oh, damn, actually, you know, and sometimes it's just a lot of memoization here and there that you need to add. But if you do it along the way and you measure regularly, you avoid this kind of stuff. I think it was here first.
My question is, what we do on iOS, for example, in case like you want to compare the upfront better with Hermes engine or not? Because it's everything now iOS.
Yeah, it's a great question. The question was, what do we do on iOS? For example, if you switch on Hermes or even Fabric. To be honest, I don't know. At this point, I've only investigated Android because it's easy and usually less powerful. But it's true that, you know, testing on iOS still remains interesting. Although for Hermes usually impacts mostly app startup time. So you do have other tools to check that. Usually it's also noticeable. I think there's another Flipper plugin actually that checks startup time by Oblador, but I forget the name. And also we have a plugin using Firebase Performance, which you can use to actually put traces in production. So you can measure actually time on all of your users' devices between startup and, oh, JS is done. Like for us, we did that and we saw that the trace, you know, when we use Hermes, but we put it in production, it just like it went down by half, basically. I forget which were the, oh, more people really. Oh, okay, wow, cool.
Do you have any other tips? So you already mentioned the Firebase trace, which is a great tip. So do you have any other questions to measure performance?
To measure, there are a lot of tools. I like this one. This one is a bit more experimental at this stage. Like, to be honest, at the moment, I'm using mostly the performance monitor on Android. Also, it's available on iOS. So the one with the Flipper plugin showing the performance, the JS and the UI threads. 60, etc. It's annoying when you come on those use cases where you want to compare pre-fabric, after fabric, and stuff like this. I know that actually Xcode has, like, if you have access to the code, Xcode has Xcode instruments, which work well and will print out CPU usage as well. Not on an app in production. Actually, that's a better answer for the question before. Like Xcode instrument, if you have your app, you could actually, it's not called Xcode instrument. Well, you can just Google it. It's part of Xcode. You can measure CPU usage, RAM usage, etc. out of the box. So yeah.
How do you measure, or how do you know the baseline of an average customer? So, there's different phones, there's tablets. I guess we're looking at your, is there like an average, almost like a business metric that if you make a change, it's going to impact, only 20% customers because they all have very fast phones, you're only going to be resolving a problem on a slow phone, which is only 5% customers. Is there sort of a business metric for an average baseline?
Yeah, that's a great question. So the question was, what's the baseline? Like, I've used a pretty good phone. It's a Samsung S10. But how do you know, like, where to stop, basically, between, catering to people with lower end Android phones? I have an article actually coming up on that. I had fun with something called Geekbench, which you might know. They benchmark phones. They benchmark phone CPU. And for example, they attribute a score for the CPU, single core CPU performance of your phone. So I believe this is 600. Then I took the analytics data from some of the apps that we had at BAM, which had like millions of users in the French market mostly, but I'm assuming the English one or maybe even European one would be the same. I have to gather more data. And I've just cross-referenced it, cross-referenced them. It's with Geekbench, and I saw that the average score was 350. However, in France, we have a lot of people actually buying very low-end device because there are still a lot of low-end devices costing like 100 or 150 euros. So it was a third of the people with a score below 200. And this is single core, which means that someone having a score at 200, it's just going to run the JS 3 times as slow as someone with 600, because 200 times 3, 600. So I like to test on a J3, which is 100, but this is kind of fun. Usually 10% of people have a worse phone, but it's up to you to define that with like how many percent of users do you want to cater. But I have an article coming up with like cool graphs and stuff like this. Well, okay, I'm maybe selling it too high now.
Thank you.
Yep.
First of all, great talk. I'm really excited to see
Thanks.
the react performance extension. But I was curious, do you have like, when you're profiling performance, do you see like common patterns of what's like performing badly? Obviously, one example would be flatness. Is there any other sort of non-performance cases?
Yeah. So the question is, when you analyze performance, what are the common bad things that happen? So, well, you have things on the JS side and things on the native side. Usually, it's going to be things on the JS side. So things on the JS side, usually memoization, like that just happens a lot because of flatlist, because of how it works, for example, but not only. Usually, yeah, memoization or even bad architecture, which means that too much stuff is going to render. So this is where the React Dev tools are helpful, because you're just going to check, oh yeah, I'm doing this. This should definitely not render. What is happening? The second thing on the JS side would be you have some components that are taking too much time to mount. So they're not re-rendering, but actually they're expensive to mount, also detectable with React Dev tools. And the third thing is I'm just displaying too many things. There was a project which had like a list of collapsible elements. And basically, when you mounted the screen, it mounted all the small collapsible stuff, but also all the stuff that was supposed to be, collapsed, and that amounted to like a crazy, enormous amount of components, which React Native or native or Flutter, like Node technology, can handle that if your phone is doing badly. And on the native side, it can often be ads. That's my nemesis, because ads usually are run in web views and usually have horrendous performance. Like I had one project where we had an ad banner, and the company in charge of designing the banner put like some images, 3000 per 1000 in resolution, just to display in this very small box. And then you complain, oh, why is the app laggy? Or React Native sucks. Well, I mean, no, fix the ad, please. And sometimes animation also, like if you have some weird animation happening in the background or something like that that you're not supposed to show, it can happen. And the easiest thing, actually, images. That's the thing that's common to all platforms. Like, make sure that you have the correct resolution for images on your app, that you do also the time 1, time 2, time 3 to adapt the resolution of the image for the device that you're using if you have local assets. Oh.
Yeah, so we've got a few questions from the YouTube chat. We've got one question here about memory leaks. So, is this a concern for you when you're making React Native applications? Is this something that you need to use the ABB shell to look for, or is this not a key?
So, memory leaks. Well, you do have on Android, you have Leak Canary, which is kind of a nice plugin for the Android world, and it's available, I think, in Flipper, which detects memory leaks. So I have to be honest here, memory leaks are more painful than optimizing a flat list, for example. So yeah, it's kind of annoying if you have that. But yeah, Leak Canary will detect the memory leak and show it what component is holding the memory leak, at least on the native side. On the JS side, I don't think I've ever used something, but I think I guess profiling with Chrome or something might work, just like the web, I guess.
Great. And another question from the chat says that your Android emulator seems to be running really well. Are you using an M1 MacBook? Have you got any secrets here? Or is it maybe that you're running a?
I don't know if I'm seen on the.
Straight through. So in this setup, is this going over the network, going over the cable?
No, it's cable. So I'm using SCRCPY from Genymotion. It's screen copy, basically.
Oh yeah.
It casts the device to my Mac screen, so that's it. And I think we have excellent internet connection here. I think some other people use some other tool, but yeah, I use this one. It works well. So yeah, it's a real device. Cool.
Okay, great, cool. Cheers, guys. So hard to get their attention, yeah. Sorry, guys, sorry. Okay, so we're going to start our next talk in a second. Cheers, thanks guys, thanks. Yeah, okay, so we're coming back. Obviously, one more plug for Immediate Media. You know, thanks again for the venue. Just for your information, we've got the space here until 9, so feel free for networking and drinks until then. And then I think we're probably going to move out after that, but probably we'll continue at the pub or something like this. Great. So great talk from Alex. Really love to see it. The next talk kind of follows in a similar vein about performance. James is going to be talking to us about the React Native Bridge and JSI and comparing them and what's coming up next with React Native. Cool.
Cool. I'll try not to fail at the first hurdle of plugging the microphone on. Cool. So in contrast, this lectern was built for my height, but I'm stuck with a small one. So so cool. If you'll pardon the pun, my talk's called The Bridge to JSI because the current architecture is called the Bridge, as many of you all know. And the new architecture, which hopefully some of you have heard of, but maybe there's not so much awareness, is this concept of the JSI. So I'm an architect developer at Theodo UK. Just recently became an architect. And so sort of on a daily basis, I work with React and React Native on a multitude of projects. So yeah, I've been asked to come and share something interesting that I know about React Native. So I actually had, I presume, similar to many people, kind of an unorthodox introduction to computer science. I was not originally a computer scientist, I was a physicist. My first exposure to computer science actually comes from my dad, who has a PhD in computer science. And he came into my room one evening whilst I was, at the end of my first year of physics, I think, and he said, "I can explain everything." He came in with a piece of paper and he said, "I can explain everything within an hour." So 3 hours later, we were still discussing bits and bytes, and I had next to no idea what was going on still. So I suppose, fortunately, I stuck with it. And he took a step back and he instead tried to teach me a bit about programming rather than CS. And I kind of got into Java, writing the basic text-based games. And then the next progression for me was moving on to writing native Android applications. So this was something that I wrote many years ago now. And it's a peer-to-peer study session organizer for students. So essentially, you can message other students, figure out what their what skills they have, and you can organize peer learning sessions. But obviously, native Android is quite a steep learning experience, and you deal with a lot of low-level stuff. For example, it's all imperative programming. So I searched this repository and found 80 instances of find view by ID. It's not what I want to be dealing with. I want to be dealing with business logic. So I joined Theodo and discovered React, and I was like, this is great. I've got my declarative syntax, which is JSX, and I don't need to deal with all of this low-level programming of the UI. And obviously with learning React, it comes with a low barrier to entry for React Native. So web developers can quite easily just jump into React Native without much extra any extra sort of level of expertise. You can kind of start developing in React Native straight off. And so I think it's important to kind of share, well, what is React Native? Because quite a few people in here I know like React or web-based developers. And I want to explain like what is the current architecture, like how does it actually work, and what sort of a high-level overview of what's going on, just to prove to you that it's not magic. Like it can seem like that at certain points. And then Facebook have actually been working on this concept of a new architecture, which is like relates to the JSI, which I want to discuss and hopefully bring or like raise your awareness on this. So step one, what is React Native? So React-based applications have like two parts. You've got a React, like the actual React library, and this purely deals with like reconciliation. This process called reconciliation, which is essentially taking your functional components and building up this thing called the virtual DOM or the shadow tree. But it has actually nothing to do with rendering. The second part of React-based applications is you've got a renderer which actually takes that that virtual DOM and decides like, what do I need to do to actually like render this to the page? So like if we look at the sort of typical create React app web application, this is kind of what you'll see in the index.js. Obviously for like a single page web application, you receive some index.html, it has a root element, and then it will run something like this. So we've got actually like the React library. So we've got, we're importing some app, we've got a functional component, and we've got a JSX syntax. And then the second part of this is like actually the thing that's rendering your app to the screen. And in most cases for, well, maybe not in most cases, but create React app, you'll probably use React DOM.render to actually render this to the screen. So what does a React Native project look like? Very similar. This will be your like app. Well, not your app.tsx, but your like index. You've essentially got the same thing. You've got React. So everything that I can do in React, I can do in React Native. But here, the things that we've switched out is essentially the renderer, which we're getting from React Native. You've got the app registry, and you're saying register this component, and you give it the root name of like the app essentially, and this goes and then finds the root component, which is somewhere in a native view, and it knows now to render that React element tree to your root view. So to summarize, React Native is a renderer for React. It's not doing anything magic. We pass it a virtual DOM. In React Native world, we kind of like to call this the shadow tree as well because it sounds cooler. And React Native decides which native components to show. So I suppose it's important to note we are actually rendering like real native components exactly as they would be rendered on a sort of regular native project. So this is what we've got at the minute. You've got your like native device, and what React Native brings to this is a JavaScript engine. In this case, it's JavaScript core. It comes with iOS, and they bundle it in with your Android application. And this has well, I don't want to say like a nice C API, but like you can interact with this through a C-based API, which comes with the VM. And then essentially on that engine, you're running your React application. And this just deals with like the reconciliation and the business logic. So exactly how you would expect to use React as a web developer. And then you have this like second side of things, which is the native project. So this is in Java or Kotlin, and for iOS, it'll be Swift or Objective-C. And that, along with the help of React Native, like the React Native library, that deals with the rendering of the UI. So just to zoom in a bit on the native side of things, I assume you guys, some people will be familiar with this directory structure. I hope so, at a React Native meetup. Essentially, you've got your source folder, which is all of your source code. And you also have an Android and an iOS folder in your React Native directory structure. And just to demystify it, this is exactly the same as any native, any native application that you might make. So anyone who's familiar with native Android development, so this will be me like 5 years ago, will be familiar with this kind of structure. So just taking a quick look inside the main application, the important thing here is just a regular main application. And we're importing some of these things from a place called com.facebook.react application. So a lot of the abstractions are actually coming from the React Native library. But something that you might notice if you've had a look around your native project is there is no place in your actual native project called com.facebook.react. Does anyone know whereabouts this actually lives, this code? Getting some shaking heads. Okay, well, yeah, the secret is it's in your node modules. So obviously every React Native project that you create, or you'll use like npm or yarn to like get the dependencies, but like the React Native source code is in your node modules, and React Native uses something called auto linking to like link the native projects that are stored inside your node modules to your actual like main application. So you can actually go digging around in the React Native source code to see what's going on. So we're kind of missing something in this picture, and it was alluded to in the previous presentation. But how do we actually, how does the JavaScript engine actually communicate with the native layer? And I think lots of people will be familiar with the concept of the bridge. But what actually is the bridge? So there's actually this like world of C++ that kind of sits in between your native project and the JS core VM. And this is where the bridge lives. And essentially all the bridge is an async batched message queue. It sounds scary, but essentially all that's happening is every time that your React application wants to communicate with your native application, it just like JSON serializes the message, batches those up, and then sends them across the bridge. So this means it's all like asynchronous. Once like your React application sends a message across, that's it, it's gone into the ether, and it expects that your native project is going to just pick that up and respond by rendering it. And actually in practice, it's split up into two sections, possibly in implementation detail. You've got the native to JS bridge and the JS to native bridge. And on the side of the native project, this is where your like native root view will live. You also have this idea of a bridge interface on the native side. So all of the interactions between the bridge kind of go through the bridge interface on the native side. And then obviously on the native side of things, you've got all the core modules that come with React Native. So that's everything in the React Native library, plus any custom native modules that you write yourself. So you can actually go into that Android folder or iOS folder, write some native code, register that as a module, and use the bridge to communicate between your React application and your custom native modules. So let's just, for the sake of demonstration, show what happens when you press a button, for example. So we're responding to a click event. Now this obviously originates on the native side of things. We're rendering native components. So the click event happens natively somewhere underneath the root view, which communicates to the bridge interface. And that gets sent along the native to JS bridge, which your React application then picks up. And it does some business logic and very simply sends back the response of whatever UI update, whatever update to the React element tree has occurred. So like the diff between the two trees goes back to the bridge interface. And at this point, React Native is deciding how to render this, and it re-renders like all of the changes that you've like that are the side effects of the click event. Cool. And it's just worth noting that this all on the left-hand side is all cross-platform. Anything that involves Java or Swift, they need to write a unique implementation for iOS and Android. And currently, the renderer kind of lives on the native side. Yeah, and this is like not, it's not magic. Like someone wrote this code, you can go and see it and like see what's actually happening. So the good things about the bridge, it's asynchronous. So it's not going to block my UI thread, like waiting for synchronous events. Another really cool thing is that it's decoupled. So as long as you follow the React bridge like command interface, you can use the React Native bridge to render native components because it is just a renderer. And so I've seen online people creating almost like Angular native, where they've connected, they've created an interface for like Angular apps, which then uses the bridge to then render their components, which is pretty cool. But obviously, there are some cons to the bridge. So we've got a lot of duplicate implementation with things being implemented like once on the native Android side and once on the native iOS side. And also, we have no way of like having any synchronous events. Like the JavaScript environment has like no way of knowing what's actually going on in the native thread because it's just sending messages. And this means that there's like no way to prioritize like UI events for as an example. So very famously, there's the issue with like scrolling flat lists. All of these updates have the same like level of prioritization in terms of UI. So there's no way of like interrupting an animation, for example. Yeah. So moving on to the new architecture, how is this going to change? Well, it all revolves around this idea of the JavaScript interface. And what does that actually mean? So has anyone tried just taking a step back and moving back to web development? Has anyone tried like printing out the value of console.log in their, like when they're inspecting on Chrome? And does anyone know what it prints out? Yeah, exactly. So we see this. It prints out the implementation, which is a function called log, and it says native code, which seems a bit, I don't know, obscure. But essentially, and I'm not sure how many people know this, like the ECMAScript specification hasn't got any mention of like console. So console is actually part of the web API. So all of your browsers will, well, depending on which browser you use. So each browser implements differently the implementation of console. So obviously all of them by convention have the console.log, but the JavaScript environment where you're actually like logging out console.log has no understanding of like the implementation details that are gonna go on when you do console.log. It just has a reference to the function that it needs to run on the native side of your device. So essentially console.log, it's running some native code, so it's not running JavaScript when you actually run your console.log. But you can call it from JavaScript. And that's essentially analogous to what the JSI is going to be doing. So previously we had this idea of the bridge, but that is going to be replaced by this idea of the JSI, so the JavaScript interface. And essentially, we're no longer tied to one specific JavaScript VM. The reason being that this is its own API, and all of the communication that happens between the React application and the C++ side of things is now going to go through the JSI. And obviously this means we discussed Hermes a bit before, which is a new JavaScript engine, which is optimized for React Native. And I think React Native are going to be pushing this a lot more with the JSI, like as they move more towards using the JSI and away from the bridge. But this is what React Native say about the JavaScript interface. It's essentially a lightweight API which allows you to embed a JavaScript engine into a C++ application. Yeah, so exactly what I've just said. It allows you to interface between JavaScript and C++. So your JS and native, so native is now, when I say native, C++, are actually aware of each other. So you're going to be able to call functions, native functions directly from JS and vice versa. And what this means is because we're no longer sending this, like sending a message across the bridge, we now have like synchronous events. Like you can just call a function exactly as you would as if it was JavaScript, like kind of in the same thread. I've discussed that it's decoupled from the JS engine because everything's going through the JSI. It should be able to switch out the actual engine that you're using. And another thing is like React Native is obviously like write once, use everywhere or whatever. But more of the implementation is moving to C++, which is cross-platform, which means that any optimizations that are made for Android or iOS, both platforms are now getting those optimizations. And also C++ is a very optimized language as well. So we've got the JSI, but how, obviously we're now actually talking between your React application and the world of C++, but JavaScript and C++ are very different languages. You've got JavaScript, which is a dynamically typed language, whereas C++ is statically typed. So Facebook are actually doing something quite nice for us. They're going to be introducing this utility called CodeGen, which essentially is going to help us integrate static typing between TypeScript and C++. You can also use Flow, but essentially what this is going to do is like if you're writing a native module now, CodeGen is going to be this tool which will allow you to generate a lot of the boilerplate code, a lot of the interfaces, and it bases that off TypeScript. So TypeScript can be your source of truth if you're ever sort of delving into the native world yourself. So we've now got the JSI and CodeGen acting as a sort of interface between the world of C++. But Facebook are actually also moving the renderer to this world of C++. And we mentioned it before. So if anyone was wondering what Fabric is, spoiler alert. So what this is doing is taking the React element tree that we pass it in some of those first slides, and it transforms that into the shadow tree. And it does a lot of layout calculations. This is kind of what the renderer is doing. It uses a library from React Native called Yoga to do those calculations. Obviously, in the web, when we're actually like writing our React Native or React code, we're in the world of Flexbox, but that doesn't really exist in the native world. So we can, instead of like using Flexbox, we've got Yoga to calculate where things are going to live on the screen. We also do this thing called view flattening, again related to the fact that we use Flexbox on the web. This was initially an optimization that they made for Android, but one of the nice things here is that as we move to a shared implementation, a lot of the optimizations that we get for one platform is shared with the other platform. So essentially what we're saying with view flattening is quite often in like HTML or JSX, you have a lot of, you use the box model on the web essentially, and this leads to like lots of nested views. And because these views are just no longer needed, React Native gets rid of all of the intermediate boxes that you're using. And this just optimizes so you're not like rendering loads of views which are nested. And only when we get to the actual mounting, like the promotion of from the old host view tree to the new host view tree, does the native side actually step in, and then we promote, we promote the tree to being the live tree. And this is called Fabric. And Facebook have been working on this for like 4 years at least now. Cool. So as I've discussed, consistency between the two platforms. We've got performance gains of everything being in C++, and any performance gains from one platform, like optimizations that we would make from one platform, get shared with either platform. Obviously, because everything is synchronous now, we can deal with prioritization of UI events and actually like interrupting UI events. So for example, if you've got an animation, you need to like interrupt that animation because a new animation is happening. You can actually do that. And another cool thing that is shared across actually all things that use the JSI is they kind of boast a faster startup time, like application startup time, because all of your native modules are lazy loaded, which is pretty cool. And not only do you get Fabric, but also you get this new thing called turbo modules, which takes into account any native, like custom native modules that you might want to write. So say you want to implement something in C++, or on the native side, or you're trying to optimize some code and you decide, okay, I want to write this in C++ rather than JavaScript. I'm just going to delve into the world of C++ for a bit. You can write a turbo module, and this is kind of the rebranding of native modules. But essentially, yeah, it allows you to gain access to native functionality directly from JavaScript, because obviously through the JSI, my JavaScript actually can call native code synchronously. What this will kind of look like is you'll have like a turbo module proxy at the global level, and you'll be able to like pick out your your specific module, and then just import that in JavaScript as normal. Yeah, and under the hood, it's called native function. So this is the promise from Facebook. 2022 is going to be the year of the new architecture. They promised us that in 2018 as well, but it's going to be the year because it all exists. So you can actually go into your node modules and you'll see these things. You'll see the JSI, you'll see the new renderer, and people have been using it. So this is the React Native directory. Okay, quite a crude search, but 7 people have specifically said in their React Native module that it uses the JSI. But I mean, this is not everyone that's just using the new renderer. So this is an example. There's a library called mmkv, which someone made. And they're comparing this. This is essentially an alternative to async storage. So they've got this comparison where they're reading a value from storage like 1,000 times. And look, it's so much faster, which is good. And they claim it's like 30 times faster than the default async storage, which is really cool. And I suppose one of the reasons that will be is there's no like batching of events that you would need to do over the bridge, because you're actually just directly calling your native function. There's another library here, SQLite at native speed. So they boast 2 to 3 times faster, which is not quite as good as the 30 times faster of the previous library. And then also Reanimated as well have essentially rethought their entire library. They've got Reanimated 2, which like changes the API completely. So yeah, people are using this. Oh, the caution is this is experimental, and your dev experience may not be as good as it will be in the future. But you can definitely start implementing your own like native modules or turbo modules using the JSI. The only thing is you might not have as fun a time. But I suppose it's quite an exciting time because there are lots of modules out there to be optimized. So we had the SQLite, which I presume someone has just been like, cool, there's this new thing, the JSI. I wonder if it makes it any faster. So yeah. So to summarize, what is React Native? It's a renderer for React. And it essentially produces physically a native project for you that uses the utilities from React Native to render your application. The bridge is the current architecture, so it connects native to JS via like JSON, a JSON message queue. And then the important things that you guys should know from the new architecture is that everything is based on the JavaScript interface, which allows JavaScript and C++ to invoke each other synchronously. The new renderer is called Fabric, which is implemented in C++. And we've got CodeGen as well, which will hopefully make our lives a lot easier when we're looking to implement our own native turbo modules. Cool. Any questions? I'll qualify that. Any easy questions?
Oh, I have a yes or no question.
Go on.
Okay. Have you had experience writing the JSI native modules?
Okay, so the question is yes or no. I feel like a politician now. Yes or no, have I myself written a turbo module in using JSI? No, I haven't. I had 3 weeks to prepare this talk. But I've seen, obviously the resources are not that great at the minute. obviously there is documentation, but it's all kind of still taking shape. So there's a lot to learn. I did see some interesting tutorials on some people like sort of trailblazing and figuring it out, but it's still very much in the realm of being quite new. Yep, go on.
I think I've got a hard one. Do you think JSI, introducing JSI, is the actual new architecture necessary? Isn't JSI just the bridge that could have been reused for the existing modules? So people would naturally write.
Okay, so the question is like, is the new architecture necessary? Are you asking?
I'm asking is could they use JSI just to make it faster and use existing modules, and then the synchronous would stay synchronous, and asynchronous could be adapted after.
Okay, so can we have like this fusion of bridge and JSI? That's a good question. So yeah, I mean, the JSI is just like a set of tools that you can use that's in the library right now, right? So you can still use the bridge.
But not the existing modules which have already been written. And I wonder why.
Oh, so like, can you use the JSI to communicate between existing? Yeah, I don't see why not. You can't. No?
You can't have a synchronous call, sorry, an asynchronous call to a function and know when that function stops. That's the halting problem with computer science.
I think
it can't work.
Okay.
Yeah, I think you can't. Yeah, but I think it would be possible if they didn't do such a practice. But I guess they must be using another. But anyway, that's
cool. Any easy questions? I don't want to be asked about the halting problem. Like I'm not a computer scientist. Nope. Cool. In that case, I will leave it there. Theodore are hiring. If you want to work with React Native, come and talk to me. But other than that, thank you.
Great. Thanks very much, James. And thanks to everyone for coming out today. Thanks to Alex, who's been recording online. Thanks to the whole React Native team, and of course, Immediate Media for hosting us. And I hope to see lots of you at the next one, which is 12th of May. So we do one every month, and it's gonna be the same venue here as well. So I hope to see you all there. Cheers. you.